To get the most out of this video, you should already know how to correctly name and label the sides of a right-angled triangle in relation to one of the acute angles. Recognise and write the expressions for the three trig ratios sine, cos and tan, and be familiar with the trig ratio buttons on your calculator. If not, I recommend that you watch the first 2 or 3 videos before continuing here. In this video, we will apply what we have learnt to calculate an unknown angle in a right-angled triangle when we know two side lengths. Recall that the whole point of the three trig ratios is that for an angle of given size, such as 30 degrees, the values for the three ratios do not change, no matter how big or small the right triangle is. In the last video, we used this fact to determine the length of an unknown side by matching the pair of sides with the correct trig ratio and the known acute angle. The correct ratio value is stored in the calculator, so we simply solved this basic equation. This time, we know both sides, and thus we know the actual value of the ratio. However, we don't know which angle it came from. We see here that the ratio is equal to 3/5, which of course is 0.6. We could keep guessing and checking like this. I think it's 25 degrees, too small. 35 degrees, it's still too small. Eventually honing in to find that it's approximately equal to 36.9 degrees. This is not very efficient. Fortunately, we don't need to do this. The second function on the trig ratio buttons, shown in yellow, will tell us the angle from which the ratio came. These functions are known as inverse sine, cos and tan, or arcsine, arccos, arctan. Although higher levels of mathematics will go into further detail regarding these functions, all you need to know at this stage is that these inverse functions will tell you which angle has a particular value for a particular trig ratio. In other words, it tells you which angle it came from. Since we know it's the sine ratio, we simply tap Shift, then Sine, then type in 3/5 or 0.6, close the parentheses, and here we see the required angle. I can round the answer to the required level of accuracy. You might elect to write the ratio as a decimal or even as a division because it can be more efficient than using the fraction key. Now let's do a couple of examples showing how to effectively communicate your method and solution. As always, it's best to start by labeling sides and determining the correct ratio. This time we have the tan ratio. In the last video, I wrote opposite on hypotenuse first, like this, since I was calculating a side and wanted the unknown value on the left-hand side of my equation. Since the angle is the unknown value this time, I might as well leave the expression as it is in the summary. The side opposite to theta is 3 and the adjacent side is 4. So we know that the tan ratio for angle theta must equal 3/4 or 0.75 as a decimal. We want the calculator to find the angle that has this tangent ratio, so we press Shift, then tan, followed by 3/4. It's good practice to show this in your solution, like this, although many people do not write this step. Personally, I recommend writing it in as it reminds you and the reader that you need to use the inverse function to find the angle. Here is my unrounded answer, followed by it rounded to the required accuracy, 1 decimal place in this example. It's worth noting that our answer is not the exact angle. It does not have an exact tan ratio of 3/4, as we see here. Even using the entire 8 decimal places doesn't exactly equal 0.75, but now the error is so minute that it is insignificant. By the way, the calculator does retain the exact value in its memory, even though you see it rounded to 8 decimal places. Pressing tan, then the answer button, rather than retyping the 8 decimal places, we'll find that the tan ratio is exactly 0.75. 3/4. Let's wrap this short video up with one last example. Press pause if you'd like to try it on your own. Labelling the sides, we see that we are given the opposite and hypotenuse lengths, so we need to use the sine ratio again. With the opposite side being 11.5 and the hypotenuse being 14.1, pressing Shift Sine to get the inverse sine function, we find that the angle is 54.6 degrees. Once you are comfortable with the techniques developed so far in this series, be sure to check out the next video where we learn how to use smaller angle parts known as minutes and seconds, in the same way hours are also split into smaller parts, also called minutes and seconds.